want more. So there you go. I gave you a better one. Those other ones, too boring. So I gave you an absolute value function and a nice little reciprocal function that has been stretched a little vertically and a square root function. So a little bit more exciting. Kind of put three together there. So again, you have 1, 2, 3. You don't have to rewrite them. You can go right ahead and just start to graph them. So 1, 2, 3. So 1, again, you don't have to rewrite it. Y is x plus 5 minus 1. So that is going to be left 5 and down 1. So I'll start with that one. I'm just pulling it aside just so it's a little bigger. You don't have to pull it aside, but just so you can see what I'm doing. So I'm going to do it in pencil again. So this is the absolute value function. Left 5, 1, 2, 3, 4, 5, and down 1. Right, so left 5, down 1. 1, 2, 3, 4, 5, down 1 like that. And it opens up. Nothing else is happening, so I'm just going to do dot, 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 like that. Now, where do I start it? I start it at negative. I'll zoom out just for a second to see the left part. I'll start it at negative 2. So it's over here, but we want that to be open. So always look open or close. So we do want it to be open. So that's going to be erase here. And this will be open at negative 2. Right? And I'll zoom in just so you can see my open circle. Okay? And then these other ones here. So now we're just doing dot, dot, dot. And then you're just going to draw it here to the left. Is that okay? And that should be an arrow on that end because it indicates it keeps going. All right. Then erase. Okay. Next one. So 2. So talking about 2, it's y equals 2 over x plus 3. This part here is a vertical times 2, right? And that's a vertical up 3. If you need to, you can do a chart where you have the x and then the y is 2y plus 3, right? So you used to do those charts. If you need to, you go ahead and do the chart. Right? If you're like, you know what, I'm finding this a little bit faster now, I can start to draw it on it, you can do that. It's up to you if you want to do a quick chart and move your points. You can move your 6 points. I'm going to try draw it on it and calculate while I'm going. So I move it up 3. Okay, so again, do this. And then this asymptote did not change. I've got that there. Now, normally the points would be here, right? But you're multiplying it by 2 vertically. So it's twice as high. Everything's twice as high. So if you can do it that way, then you know that instead of being at 2, it's going to be at 4. Instead of being 1 up, it's 2 up. Instead of being half, it's 1. So if you can do the calculations a little faster, I don't need the chart. Okay, so last year we were like, we'll give you part marks for the chart. If you want to go straight to the graph, you can. Okay, and then here, so these points will all be times 2, vertically times 2 higher. How far am I going to go here? So it's going to be 1/3 here. So this one's going to be here, but it's twice as high. So I like to draw it, and then I double it. So it should be here. So that is going to be double, and that's open and open. So take a look. How do I draw an open on an open? Open on an open is just open. Doesn't close it up, right? So open with a solid would close it up, but open on an open is just going to be open. So I still put a circle there. This, instead of being 1 down, it'll be 2. Instead of being 2 down, it'll be 4. Right? So I'll zoom in. I know it's hard to see, so let me zoom in. Is that closer? Is that better? A little bit better? Okay, and then this side here, right? So where the asymptote is, so I'm going to draw my asymptote again. And so instead of being 1 up, it's double. double, and double. So you can see that's where I did my calculation. So if you can do it that way, shoot, where do I stop it? 4, 1, 2, 3, 4, crap. And let's take away that. I went a little too far. And should that be open or closed there? Should be 4, open. So that's an arrow, and that's an open circle there. And erase the extra. They won't all be this complicated. I did try to give you 3 different functions so that we could practice them all at once. Our last one is just the square root function, so that's a little bit easier. It's going to be to the right 3, so it'll be here. Right, and I would do solid dot here over 4 up to like that, but it's asking for greater than or equal to 4. So I can't, remember, vertical line test, I can't overlap. So I doesn't want that dot. I would do a solid dot here at the 4 and then head to the right. So I'm going to do solid dot here and head to the right. Like that. And erase this dot there. And it is discontinuous, right, at x equals, this would be -2. And the type, what type is that one? This one here, that's discontinuous. What type? Yep. Jump, is it jumping from one point to another? So jump is going to be jumping from one point to another. Yep. Sorry? Point, yes, or removable. If something's gone or a point's missing, right, so removable or point. So you can say point or removable. So point discontinuity, okay, or removable, right? So anything missing is a point or removable discontinuity. Okay. And then here, that would be the jump. Right, so at x equals 4, and that would be a jump discontinuity. And at x equals 0, everyone forgets the asymptote. They're like, wait, oh, it's part of the graph, so you're so used to seeing it. That is an asymptotic or a infinite discontinuity. Either word, you can go with either one, asymptotic and you can shorten it. So it's asymptotic discontinuity or infinite discontinuity. Is that okay? I'll zoom back out. In university, don't shorten it like that, but if you put asymptotic, yes.
Will we also do a asymptotic discontinuity at y equals?
Oh, good question. We're not doing horizontal. We're talking about as you're going left to right. So this graph is, there's a hole, right? Point discontinuity, or removable, asymptotic, and then a jump. We're not doing a discontinuity up and down. We're doing it left to right. As you're scanning the graph left to right, what's happening? So it's always with respect to the x values, yeah. Right, so you're like there, there, and there. So as you scan left to right, yes?
Why does the square root function start at y equals 1?
Because it actually starts, I know, that's why I gave it, it starts here. And it goes over 1, up 1, and then it goes 4 is 2, but because I removed it, it no longer looks like it. Yeah, I know. That's why I did it on purpose, because removing that first dot, you're like, what happened? Right, it looks like a stretch, but it's not. Yeah. Okay. Any other questions with that one? The next question is backwards. I drew the graph, and I want you to write the equation. Some people like that more, some people like that less. Let's see. So example 2. Are you ready? Let's move it up a little bit. All right, so let's start. I always start left to right. We're going to do our nice little function notation, so f of x or g of x or whatever you'd like to call it. And then we're going to do curly bracket, and let's just put our answer. So I can see two functions here, the reciprocal function here and the square root function here. So for the reciprocal function, I know that it has been shifted left 3 and up 1. So just start it. Start it with something. So I'm going to go left 3. So I'm going to go x minus 3. Oh, sorry, plus 3. Because it's opposite, left 3. And then plus 1. Right, so I'll do, and then if, and then we'll have to do a restriction part. So we did that. Now the normal restriction, normal reciprocal function should be here and here in these two quadrants, right? But it has been reflected. So it's either been reflected vertically or horizontally. It doesn't matter. For a reciprocal function, a vertical and a horizontal reflections are the same. So I don't care if you put the negative on the top or the bottom. But if you put the negative on the bottom, you need to put the bracket, right? Because remember, it's not part of the translation. So it's easier if you just put it on the top. Right? Then you don't have to remember the bracket. Is there any stretch or compression? So it's usually over 1, up 1, right? And at half, so look, over 1, up, it's twice. So it's twice as tall. So we just did that exact opposite on the graphing question, where we made it twice as tall, right, from that asymptote. So looking at that, hopefully you can go backwards and say, yeah, if I give you it twice as tall or 3 times as tall, you can see the stretch. Okay, so that's good for that one. The restriction, or the domain for this one, is going to be to the left of -1. So x is less than or equal to -1. Make sure you have the equal, not equal to looked at. That is a solid dot. That's about as obvious as I'll try to make it, right? For this one, going to give me the equation. It looks like a square root function because I gave you those dots there. So it's going to be, you don't have to do the y equals because it's already there, and it's going to be square root. It's going to be shifted left 1, up 2, right? So x plus 1 plus 2 on the outside, and this is if x is, and you're going to say greater than -1, not equal. Okay. There should not be 2 equal signs on top of each other, right? Like 2 solid dots on top, because there would be something wrong, because it's not a function. And everything we give here, look, it says it's a function. Following function, it's a function. Questions with that one? Okay, I did one more. I got lazy. I used one graph, and I put like a bunch of stuff on it. This was like, I don't want another grid. So how about we do, how many do you see here? How many functions? 4. So I just got lazy, honestly. I just was like, let's do one of each. So I did an absolute value. You can see a linear, and I want to show what to do if it was like horizontal, parabolic, right, quadratic, and then another linear. So let's do that. So we got 4 functions. First one looks like just the absolute value function. I'll zoom back out a little. There we go. So we're going to do f of x, or whatever function name you want to call it. Leave a little bit of room here on the bottom, because I'm going to explain how to do this line if you've forgotten how to do the equation of a line. All right, so I'm going to do equals. Leave a little bit of room here on the bottom, because I'm going to show how to do this line, because sometimes we've forgotten how to get the intercept again if we can't see it. So for this left one here, I always go left to right. We've got the absolute value, and it's been moved left 4. So this is going to be x minus 4, plus 4. Keep doing that. Right, left 4, up 1, so plus 1. And any stretch compression looks like twice as tall, right? So instead of over 1, up 1, it's over 1, up 2. So I'm going to put the 2 there. And this is x is less than -2, but not equal. Less than, not equal. Watch your signs. Right, we're watching all of these equal and not equal. for a horizontal line, it is just whatever the y value is. So that's going to be 1, 2, 3, 4, 5, so 5. Y equals 5, and that's between, x is between -2 and 1. -2 and 1, not equal, because open. And then, look, you want to put equal or not on the 1? Sure? Okay, let's put the equal because it's a solid dot. Now that you've made that decision, here, then you have to make sure, so this one here, that when you do the parabola, right, the quadratic equation, you don't double equal it. Because you'll say it's a solid dot, but you can't put both of them as solid dots because then you're overlapping, and then it's not a function. And it distinctly says that these are functions. Okay, these are piecewise functions. Yeah.
Could you do it like the other way around as well?
Yes, you can. So you can leave that one open and the other one solid, as long as
It's
only.
one point at,
But you're
halfway.
stating that it's overlapping, that you have 2 points on top of each other. So it's not. Okay, so you don't overlap it. Yeah, so one or the other. This one could be open and the other one solid. This one could be solid but the other one open, but you're not going to state it 2 times. Okay, so over here, we've got the parabola. So we've got x. It's just regular, right, shape, because there's no stretch or shrink, so I'm not going to do anything there, but it's moved to the right 3, so -3 squared plus 1. Oh, I forgot to put if. If. So I usually put if. If, and I do if. Okay, and this will be from 1, and then x is between 1 and, looks like 2, 3, 4. Okay, and again, choose. So you choose which one of those are equal. So I'll say choose. One of them is equal, not both. Okay, just choose one of them. It doesn't matter. Sorry, and this is going to be, again, same thing. Do you want it equal or not equal? One of them can be equal, one of them can't. I'll put equal, and again, that'll be a choice with the next line. But don't double up. All right, this last one is the equation of a line. Y equals mx plus b, which is normally totally fine. Except for here, you cannot see the b. I purposely tried to give you one, so if I go backwards, you can see the rise and the run. So if I go back, it's 2, up 3, 2, you'd have to count, which is fine. If you can count and find the right y-intercept, just count the number of squares up, so that's good. What if I gave you one that was further away and you could not see the y-intercept at all? I just want to refresh your memory. In grade 9, long, long ago, okay, we did y equals mx plus b. So if you can't count the squares to go backwards, you can for sure in this one, right? Just back 2, up 3, back 2, up 3, and keep going to find the y-intercept. But if you can't, we introduced you to this. Y equals mx plus b. We put the slope, which we know is -3/2, right? We can see the slope is here. -3/2 from this. Okay, that's the slope. And then we put in the point. We have 2 points to use for this. It's either 4, 2, or this one would be -1, 2, 3, 4, 5, 6. So 6, -1. Okay, for that one. Either one of those 2 points you can put in here. Okay, it's up to you. Again, back to grade 9. That's why I want to refresh your memory. So in case you can't count the squares back and find the y-intercept, you put in one of those points and the slope, which you can see. And so I'll choose 4, 2. So it'll be 2. M is, 2. And x is 4 plus b. Solve that, so that'll be -6 plus b, so 8 equals b. Right? So you go ahead and solve that. Then you put that back in to your equation. Again, if you can count it, that's fine. But if the graph is so big or so far away, you can't count the squares, because sometimes this maybe is way over here and you can't get enough squares to count it accurately, just go back to the equation. Go back to grade 9, y equals mx plus b, put a point in, the m, and find your b. And then your equation would be -3/2x plus 8 if x is greater than 4, but again, choose. Right, so choose here and here. One of them is equal, one of them is not. Okay, that's just to refresh your memory. If you can't find the y-intercept graphically, go back to your grade 9 skills and find it that way. Want me to zoom in a little? If you ever want me to zoom in, just let me know.